Hello, my name is Paul Riquette, and we are the Sheehan STEM team, and this is our presentation for our critical design review. Throughout this presentation, we will go through our mission statement, which is to design a new and innovative fire heli tanker water dispersion system, and we will go over our project plan, our schedule, as well as our team organization, dealing with who did what, and show how we did things, and then we will lead up to our final design of our prototype. And then we'll talk about the risks involved in creating the prototype and how it will function. And we will test these risks in our system requirement and verification matrix. And lastly, we will summarize everything throughout the presentation.
Hi, my name is Gretchen Sykes, and I'll be going over our project schedule and our team organization chart. So here's our schedule. Basically, over here you can see our main goals, and then the dates we plan to get them done by. And then over in green over there, you can see if we were on track or not. So green means we were on track, red means we weren't. On our next slide here, you can see our team organization chart, and the basic gist of it is we broke down into two groups. We have our research and design team and our programming and electrical team. They're kind of arbitrary, and we flip between the two a lot.
Alright, hello, my name is Ryan Lagasse, and I will be explaining our final design today. So as you can see, our final design is pretty simple. We have two separately powered motors powering these shafts, which in turn spin a cable which is attached at these 2 points, which we can use to either tip, which since we can control individually, we can use to tip the bucket and pour water out, and use to lower down and pick up water. And right here is our passive mechanism, but I'll get into that later. Alright, so right here we have our risk matrix, where we ranked our risks, which we chose to be the bucket tipping, the rotational horizontal movement, the cable disengaging from the pulley, the cable getting tangled in outside objects like trees, losing water from vertical shock, and water splashing on our electronics. So starting off with the bucket tipping, since we have both sides of our design powered by both shafts powered by two separate motors, that allows us to specifically control the bucket and make sure that it doesn't tip. We are able to control our horizontal shift, as you can see right here. We increased our fleet angle to make sure that the bucket would be stable at all times. As for the cable disengagement, we made sure to make very large knots going through these plastic parts to make sure that it was very secure. And for entanglement, we have this passive cutting mechanism that I designed that once the tension increases to a certain point, it will automatically cut the string much faster than a pilot could, making it much safer. And then finally, for shock to the payload, we plan on implementing certain codes to automize the whole entire process and make sure that the bucket is always stable and avoids any jerk. Hello, my name is Brennan Lagasse, and today I'm going to review the system requirement verification matrix and the qualification testing that we performed during this module and the previous module. The system requirement verification matrix and qualification testing were both done to provide that the team has met all of the qualifications presented to us both by Sikorsky and the FAA. The system requirement verification matrix is a tool that we used to figure out how we could test these criteria, which we subsequently tested with qualification testing. For each requirement, we paraphrased the requirement and then figured out criteria to determine if it has met that requirement and a method of establishing if it meets that criteria. And we accomplished this through various sources, including Onshape and Tinkercad. Here you can see the second half of the system requirement verification matrix, where we have the rest of the SSC requirements and some of the FAA requirements. One of the major parts of this qualification testing was with SSC 004, which was about the system being able to be integrated with the rig that the customer provided, and we designed our system in CAD to ensure that this would happen, as can be seen in both pictures here. Another requirement that we had to meet was SSC 007, and a derived requirement that we made ourselves that ensured that we could control the system remotely, which we're able to do through an electrical simulation with a controller that we built. Finally, we also reviewed that the retractable mechanism would never exceed the 4.5 pound limit load unless an external force was applied on it by determining the max weight of the bucket if it were full. And we also determined that at the speed where the bucket is full, that the mechanism would be able to operate with sufficient speed and torque to lift it in a timely manner using limits that we determined, and this testing was also a success.
Hi, my name is Connor Howard, and in this presentation we outlined our project schedule, team organization, final design, risks and mitigations, our SRVM, and our qualification testing. Thank you guys for listening to this presentation.